Hello everyone, welcome to Maths Misfit, and this is Meena teacher here. Today's video is all about the second part of logarithms, whereby we will be solving higher level problems and we will be using the laws and properties done in the previous video. All right, so let's go ahead by solving a few sums based on the laws and properties done in the previous video. Our first sum is here. Now, if you look at what is given to you, you need to find the value of this. Okay, so what are we going to do is simplify this. So we'll get log 5 into 125 can be written as 5 raised to 3, and this can be 25 into 25, and the whole thing divided by 25. So what happens here? This 25 goes, and we are left with log 5 raised to 3 into 5 raised to 2, the whole thing to the base 5. Now, this comes out to be log 5 raised to 5. What are we doing here? We are using the laws of indices. That is, a raised to m into a raised to n is nothing but a raised to m plus n. So what are we going to do here now in the next step? The next step, we will be using our property of logs. That is, this 5 will come here. And the property that we are using, what we have done in our last video, you have log of a raised to m to any base, say x. This becomes m log a to the base x. And in the last step, log of any number to the same base becomes 1. So the property that we are using here is log of any number to the base, same base, is equal to 1. So your correct answer over here is going to be the B option, which is 5. So here we have used indices as well as this two properties of logs. All right, we go on to the next sum now. Now the next sum is here. What is the value? Now again we need to find the value. So what we are going to do here is the first step, log 5. The 100 I'm going to convert into 10 raised to 2 to the base 10 here, and this whole thing is a square. So we know that log of 10 to the base 10 is going to be equal to 1. So what do we get here? This will be log to the base 10. Now this whole thing here becomes 1, and this 2 will come here. So this will become 10 log 10 to the base 10, and the whole thing square. Obviously this becomes 1. So what I'm left in the bracket here is just 10 log 10 to the whole square. And again, log 10 to the base 10 is 1. So we get a 1 square, which is 1. So our final answer here is the A option here. All right. Now there is only one property that we have used here, and that is over here, where we have got this. Okay. We go on to the next sum now. Log of x to the base 1000 is equal to 1 upon minus 1 upon 3. Directly here, we are going to convert logs to index numbers. Okay, that is the property that we are going to use here. Now, how do we use this property? So this will become x is equal to 1000, the whole thing raised to minus 1 upon 3. We have got rid of the log and we have got a simple linear equation. This I can write as 10 raised to 3 into minus 1 upon 3. This goes. So x is going to be equal to 10 raised to minus 1. In other words, it is going to be equal to 1 upon 10. So our final answer here is the A option. All right. Now come to the next sum. Log of under root 8 upon log of 8 is equal to. So the first thing we know is under root 8 can be written as 8 raised to half. So in my first step in the numerator, I'm going to put this as 8 raised to half upon log of 8. Then using the property, again what we used in the first sum, this would become half log 8 upon log of 8. What is the property that we have used here? Log of a raised to m to the base x is equal to m log a to the base x. Now here what happens? Log 8 cancels and we are just left with the answer half. So a correct option is the C option here. Let's go to the next sum. Log 5 to the base 10 plus log 5x plus 1 to the base 10 is equal to log x plus 5 to the base 10 plus 1. Like we have done in the first video, this is an equation given to you. So the first step that you need to do is convert that 1, what we have, in the form of a log. So my left hand side remains as it is. Except on my right hand side, where I have a 1, I'm going to put log 10 to the base 10. Now I'm going to use my product law. Now what is that product law? The first law that we did, log to the base 10. The plus which is here becomes a multiplication in the bracket. Same thing we are going to do on the right hand side. The plus will become a multiplication. This is called as the product law. Okay, now mentally, as we did in the last video, mentally, just cancel that log 10, 10 on both the sides, and this is what you're left with. A simple linear equation. Solve this linear equation and you will get your answer for x. So let's see what we get. I'll get 25x minus 10x is equal to 50 minus 5. So this is 15x equal to 45. So x is going to be equal to 3. So correct answer here is the B option. All right. We have used the product law here. Okay. Now you have three values which are in arithmetic progression. Now you all know what is arithmetic progression. So if we have A, B, C in AP, then 2B is equal to A plus C. So over here, we are going to use this property. So I'll get 2 log 2 raised to x minus 5 to the base 3 equal to log 2 to the base 3 plus log 2 raised to x minus 7 upon 2 to the base 3. So using our properties, the first step that I get here, log 2x minus 5. Now this 2, which is there as a prefix here, I am going to convert this using a property. So this will come as a square here. So this will become log of 2x minus 5, the whole square to the base 3. And here we'll be using the product law again. So this will be log 2 into bracket 2x minus 7 upon 2. Mentally, as we did, we just cancel this. So what I get here is 2x minus 5, the whole square, is equal to 2 into bracket, 2 into bracket 2 raised to x minus 7 upon 2. Now here, what we have done in indices earlier, maybe in your school days, let this be equal to some a. So what I get in the bracket is a minus 5, the whole square, is equal to 2 into a minus 7 upon 2. Open out this bracket, so you'll get a square minus 10a plus 25 is equal to 2a minus 7. The 2 and the 2 cancels. So what we get here is a square minus this becomes 12a plus 32 equal to 0. Now you have a quadratic here. So once you have a quadratic, solve this and you will get two brackets, factors of 32 to give you 12. a minus 8 and a minus 4 equal to 0. So you get two values of a. A is either 8 or a is equal to 4. So if you put back, resubstitute the value of 8, you'll get 2 raised to x is 2 raised to 3, or 2 raised to x is equal to 2 raised to 3. Now this option we cannot take. What is the reason for this? If you look at this value over here, 2 raised to x minus 5. If you look at this value 2 raised to x minus 5. Now, 2 raised to x minus 5. That means 2 raised to x has to be greater than 5. So, in this case, the option that you have, 2 raised to x equal to 2 raised to 2, we cannot take. So, what do we get here as a final answer? X equal to 3. This is from here, the bases are the same, so the index numbers will be equal. So what happens over here? X is going to be equal to 3. And this will not be a valid answer. So we just have one final answer, and that is X equal to 3. So our correct answer, the correct option that we have here is the D option. Now here, if you see, we can write 0.008 as 8 upon 1000, which comes out to be 1 upon 125, and this can be written as 5 raised to minus 3. And 81 can be written as 3 raised to 4, which we can convert it to under root 3 raised to 8. Why this under root 3? Because we have got an under root here. So the value of this now becomes log of 5 raised to half. For the 0.008, I'm going to put it as 5 raised to minus 3, plus for 81, I'm going to put it as under root 3, the whole thing raised to 8, and to the base under root 3. So this becomes half log 5 upon log 5 raised to minus 3 plus 8 log under root 3 to the base under root 3 minus 7. So this will become half into 3, and then I have log 5 upon log 5 plus 8 minus 7. This goes, and we are left, sorry, there is a minus 3 here. So this will become minus 1 upon 6 plus 1, which turns out to be 5 upon 6. So your correct option is the C1. See what we have done here. This half has come here, and this minus 3 has come here in the denominator. The property that we have used here is log of a raised to m to the base x, which is m log a to the base x. All right. as a single log. So your answer is going to be in a log. 2 plus half log 9 to the base 10 minus 2 log 5 to the base 10. So the first thing we do is convert log 2 as log 100 to the base 10 plus log 9 can be written as 3 raised to 2 and this 2 will come here minus log of 5 square. Now we are using the property in the reverse manner. Which property are we using over here? Log of a raised to m to the base x is equal to m log a to the base x. What we have done is we have used it in the reverse way. So in my second part over here, this 2 and this 2 cancels. Now if you look at all this, they are all logs to the same base. So we are going to use our product and our quotient law. So with this plus over here, this will become into 3. With the minus here, this will become divided, that is 5 square will become 25. 25 ones are, 25 fours are. So your final answer is log 12 to the base 10. Our correct option is the A option. So sometimes when you are using the properties, now which properties? Like the ones over here, what I have written here, log A to the base, log A raised to m to the base x. We are using it in the reverse way. Okay? We have to do this sometimes. Use it in the reverse way like what we are using the quotient and the product laws. So here what we have done is we have used two properties here. Log of x to the product law, that is log of x to the base a plus log of y to the base a. Now we have used this property in the reverse way, and in the same way, instead of the multiplication, if you have a division, we use it in the reverse way. Okay, let's go to the next sum. If x is a real number such that log 5 to the base 3 is equal to log 2 plus x to the base 5, then which of the following is true? The first thing that I'm going to take here is 1 is less than log 5 to the base 3 is less than 2. Now how do you get this? Very simple way. If I write this as log 3 to the base 3 less than log 5 to the base 3 less than log 9 to the base 3. Now 9 can be written as 2. Why we can write it as 2? Because this will become log 3 square to the base 3 and then this comes here. So I can write this as 1 is less than log 5 to the base 3 is less than 2. But we are given in the sum that log 5 is equal to log 2 plus x to the base 5. So I am going to write this like this. Instead of the log 5, I am now going to put what it is equal to. That is log 2 plus x to the base 5 is less than 2. Okay? So if you look at this, what I have done here is I have taken what is given to me. That is this. All right? Now, our middle number is a log and both the other numbers are numericals. So I am going to convert the log to index number on both the sides. So this will become 5 raised to 1. The log will go off. 2 plus x is less than 5 raised to 2. 5 minus 2 will be less than x, less than 25 minus 2. This is an inequation which we are solving here. You have done inequations earlier. So very easily you'll see solving this, you will get your answer as 3 is less than x is less than 23. So our D option is the correct one. Now understand here, this property that I have taken over here. 1 is less than log 5 to the base 3 less than 2. And the reason for this I have explained here in the next step. All right. Once that is given, you will get your answer very easily. Okay. Let's go to the next sum. Solve for x. So this is an equation relating to logs. What I'm going to do is, in the first step, I am going to convert log to index number. So I will get log of x to the base 3 equal to 2 raised to 4. And then again I'm going to convert the log to an index number. So this will be 3 raised to 2 raised to 4 we all know is 16. So this will become 3 raised to 16. This is a very simple sum. You have converted logs to index numbers twice. Okay. So your final answer in this case will be option D. We have got log 2 to the base 10 equal to P, log 7 to the base 10 equal to Q, and then we need to find log 28 which is to the base 5. So log 28 to the base 5 can be written as log of 4 into 7 to the base 5, which further can be written as log 2 to the base 2 into 7 to the base 5. Using my product law, I can write this as 2 log 2 to the base 5 plus log 7 to the base 5. So what am I asked? I get this here as 2 log 2 to the base 5 plus log of 7 to the base 5. All right. But if you see what is given to you, it is all log 2 to the base 10. But what we have here is the bases are different here. That is, I have 5 and 5 as the base. So I need to convert this. I'm going to use my laws here. This I will make it as 2 to the base 10, and this will become log of 5 to the base 10 plus log of 7 to the base 10 upon log of 5 to the base 10. So if you look at your numerators, they are the values which you already know. So this becomes 2p plus q. The denominators are the same. That is log of 5 to the base 10. Now log of 5 to the base 10 we don't know. So we need to find what is log of 5 to the base 10, which I can write it as log 10 upon 2. Instead of 5, I'm going to put it as 10 upon 2 to the base 10, which further I can write it as log 10 to the base 10 minus log 2 to the base 10. We are using our quotient law here. And if you look at this is nothing but 1 minus p. So finally, what will our answer be? Our numerator is 2p plus q, and the denominator, which we have separately solved, comes out to be 1 minus p. Get this very clear. This step, what I have done here, that is for the log 5 part, log 5 to the base 10. Now that is an important part that I have done here. Okay, which I have converted it as log 10 upon 2 and got the answer in what we are given. So our final answer from the options that we have is 2p plus q, which is nothing but the C option, 2p plus q upon 1 minus p. Let's take the next sum. Solve for x. Now this is a very, very simple sum. Log x. Now 125, I can write it as 5 raised to 3, and log of 1 upon 5, we can write it as 5 raised to 1. So this will become log of x equal to 3 log 5 upon minus 1 log 5. Again, what property are we using? Log of a raised to m to the base x is equal to m log a to the base x. Okay, so what happens here? Now this log 5 goes, and we are left with the answer minus 3 on the right hand side. But our left hand side is in the log form. Now when there is no log given, it is understood as x. Now what are we going to do here? Convert the logs to an index number. So this will be x is equal to 10 raised to minus 3, which is nothing but 1 upon 1000, which we can write it as 0.001. So our option number 3 is the correct one. All right. Let's take the next sum. Log of 5 plus log a to the base 2 is equal to 3. Log of 4a plus 12 plus log b to the base 2. The whole thing to the base 5 is equal to 3. We need to find the value of a plus b. So in this case, we will need to find a separately, b separately, and then get the final answer for a plus b. So let's take the first part. Convert the first part to an index, log to an index number. So I'll get 5 plus log of a to the base 3 equal to 2 raised to 3. I am doing this from here. So this will become log of a to the base 3 equal to 2 raised to 3 is 8 minus 5. Again, I am going to convert this. So this will be 3 raised to 3. Converting again a log to an index number. So I've got the value of a as 23. Now once you get the value of a, what we need to do is find the value of b. So let's take the second equation. Again, in the first step, we are going to convert the log to an index number. So we'll get 4a plus 12 plus log of b to the base 2 equal to 5 raised to 3, which is nothing but 125. Put the value of a, which we have got over here as 27. So 4 into 27 plus 12 plus log of b to the base 2 is equal to 125. It's a simple value that you can get. Log of b to the base 2 is equal to 125 minus 4 into 27 is 108 minus 12, and this comes out to be 120, so this will be 5. Last step, convert the log to an index number again. So b will be 2 raised to 5. So now we have the values of a and b. We have got a as 27 and b as 32. So we can get a plus b. That will be 27 plus 32, which is nothing but 59. So our correct option is A. Just go through the sum again. From our first part, we got the value of A. Second part, we got the value of B. And in both the cases, we have used conversion of logs to index numbers. Find the values of a and b separately, add them to get your value of a plus b. Our next sum, log of 2 into 2 raised to 2 into 2 raised to 3, this is up to 2 raised to m, the whole thing to the base 2. Now, the first step, I'm going to use the properties of law indices here. This will be 2 raised to 1 plus 2 plus up to 9. All right. Now, if you look at this, what we have here, 1 plus 2 plus up to 9. This is nothing but sum of natural numbers. And we all know the formula for sum of natural numbers, n plus 1 upon 2. My n over here is 9. So S9 will be 9 into 10 upon 2. So this is 45. All right. So what do I get here now? This will be log 2 raised to 45. The sum of the terms which we have got here as 45. Using our property 45 log 2 to the base 2. Same property what we had used earlier, log of a raised to m to the base x is nothing but m log a to the base x. And as you all know, log of any number to the same base is 1. So this becomes 1 and our final answer is 45, which is the option B. All right. Now, we have done a number of sums today, taking up different properties. In the last sum, we have also used sum of natural numbers, and in the previous sum, we had also used arithmetic progression. So, you need to know your basics of arithmetic progression, sum of natural numbers, and maybe some other concepts also, which can be used in different sums. Okay? These are not the only type of sums that you can get. And these are few sums that I have taken. Like, subscribe, and share. Share with your friends who are appearing for the competitive exams so that it will help them. See you in my next video. Bye. Do take good care of yourself. Bye bye.